Hello, everyone. In this video, I will go over problems in AMC8 Plus Week 4 practice, which is also the last assignment of this summer's practice program. All right, first, let's look at question number 1. Here says, we need to write the fraction 25/19 as the form of integer plus a fraction. You see, when you look at the fraction, clearly this is a fraction which is less than 1. That means as a first step, we just need to write 25/19 as integer plus a fraction which is less than 1, right? Between 0 and 1, okay? And then clearly what we can do is 25/19, that is 1 plus 6/19. All right, this tells us this p will simply be 1, and this one will be 6/19. Now, but what we really want is something that has 1 in the numerator. How should we do that? What we can do is step 2. Okay, so step 2, right, let's continue this. How should we write this as something that has 1 on the numerator? We just flip it, right? So, okay, so here's 1 plus 1/19/6. Now, what we want to do is step 2. You see, we want to write 19/6, this as something which is q plus 1/r. All right, so we write 19/6, which is, so this is integer and then plus fraction is 1/r. Clearly, what we can do is this is 3 plus 1/6, okay? And then this just tells us, okay, so this one will just be q and this is r, right? If we combine all these things together, we get a p is 1, q equals 3, and r equals 6. And what we are looking for is the multiplication of the 3 integers. We just multiply together, all right? And this gives us the product, it's just 18. Question number 2. If we have 4 factorial, so the number is 4 factorial, factorial, or 4 factorial equals a factorial. And the question is, what is the number a, which is integer? For this problem, the main issue is we need to remember the definition of the operation factorial. Let's recall the factorial. So n factorial, which by definition is n times n minus 1, n minus 2, and all the way, say, times 1 and times 2 times 1. We know this just represents, say, if you have n different items, you want to arrange them in various orders, then the number of ways you can do that is n factorial. All right, okay, so then what is 4 factorial? 4 factorial by definition, 4 times 3 times 2 times 1, which is 24. And therefore, we just replace this by 24, this by 24, and we get a 4 factorial over factorial is equals 24 factorial over 24. Now, we just apply the definition of factorial. What is 24 factorial, right? So 24 factorial is just 24 times 23 times 22 times 21 and right? All the way to, say, 2 times 1 and divided by 24. Now, clearly, 24 and 24, they just cancel with each other. And what remains is 23 times 22 times 21 and times 2 times 1. Now, what is this? By definition, this is nothing but just the 23 factorial, right? Which is a factorial. From here, we immediately conclude that a is 23, right here. Question number 3. This problem says we have 3 pieces of paper. Each of them are in the shape of equilateral triangle, and they're transparent. Each one is divided into 49 congruent small equilateral triangles, and some of them are shaded. Now, what we do is we put them together, overlap. And the question is, we need to figure out what is the number of shaded equilateral triangles we can see if you put all the 3 together, overlap. Now, when we observe this picture, it's clear if we put them together, let's say we just look at the first one, right? The other 2 are just put under it, overlap. And then we see this is, we have 4, right, from here. And then we also have one more here, right? So these 2 we have here. And then we also have this one is from the other. Here also this one, and this, and this, and that's it. So the point is, if you add this together, if you look at the first picture and those one I just added are the more are those extra that small shaded triangles we can see. All right, let's count them. Okay, so how many then in the first layer, which is 5, and then we have the second layer. This is 4. All right, and then let's look at the third layer. This is 1, 2, 3, 4, so which is 9. And then let's look at the fourth layer, right? So what we have 1, 2, 2, 3. Okay, so this is 7, right? So it's 7, and then the last we have is 6. Right? So this is the total number of shaded triangles we can see when we put the 3 pieces of papers together. All right, let's add them. So it's 5. So we get is 5 plus 4 plus 9 plus 7 plus 6. Right? So this is 9. Right? So 9 plus 9 and plus this is 13. Okay, so it's 18 plus 13, which is 31. Right? So 31 is the total number of small equilateral triangles, really small equilateral triangles we can see finally. Question number 4. Here, so this notation means the largest integer less or equal to x, and it has a special name. It's called the so-called floor function. Right? For example, if I have, let's say, this 2.2, and this will be just 2, because 2 is the largest integer that is less or equal to x, right? So this x, if x is 2.2. Or we say, okay, if I have like 1.4.1, right? So then this one will be just 1, because 1 is the largest integer that's no greater than 1.4.1, right? If it's integer itself, let's say it's just 2, then of course it's just 2 itself, which is clear. Okay, now here we are looking at the square root, right? Square root. Okay, if we want to find the integer, let's recall those perfect squares, right? Where 1 square equals to 1, and 2 square equals 4, right? 3 square equals 9, 4 square equals 16. But 5 square equals 25, but 25 is already greater than 20. All right, so here we have the square root of 4 is 2, square root of 9 is 3, square root of 16 is 4, right? Square root of 25, which is 5. Right? Okay, all right, and this tells us if we just look at the integer part, if we start from the square root of 1 and to square root of 2 and square root of 3, they're all equal to, if I look at the integer part, right? So we look at the integer part, the floor function, they're all equal to 1, because they do not, they're all less than 2. Right? And then if we look at start from square root of 4, right? And then all the way to square root of 8, because square root of 9 is 3, so that gets 3. Right, so each of them is less than 3, but it's great. It's no less than 2, so we have each of them is 2, right? If I take the integer part, so here I take square root, and then we look at the integer part square root 9, and then all the way to the integer square root 15, because he has 16, right? Okay, so each of them equals 3, and the last one will be started from the square root 16, take an integer part, which is just 4, right? And all the way to square root 20, take this, and they're all equal. Each of them equals 4. All right, so we need to add them together. If we add them together, right, so we have the sum. We just add everything together. What do we have? Okay, we have 3 of 1, and we have 5 of 2, and then we have 7 of 3, and here we have 5 of 4, right? Okay, so this is 3 plus 10 plus 21 plus this is 20, right? If you sum them up, the final result will be 54. So 54 is the sum of floor functions of those numbers starting from square root 1 and to square root of 20. Question number 5. The problem says the full price of a ticket. So we have the full price of a ticket equals $10. But if we have a matinee ticket, okay, so we have a matinee ticket, the price is only 70%, right? So it's 70% times 10, which is $7 each. Now, and they sold a number of tickets, and 30% of them, so 30% of them is a matinee ticket, And then of course, 70% were just 70% tickets were sold in full price. And the total revenue is $1,001. The question is how many tickets are sold in total? Well, the most convenient way to solve the problem is to introduce a variable and we set up equation. So let's say the X is the total number of tickets. That includes both the matinee and the full price tickets. All right, and then the number of matinee tickets will just be 3 over 10 times X because 30%. And the number, so there's the number, and the number of full tickets will be 7 over 10 times X. All right, and then we can set up the equation using the total revenue. The total revenue has two parts, right? So part one is from the matinee, so it's 3 times 10x, but matinee is $7 each, so times 7. And then the second part is from the full price ticket. Full price is 70%, 7 over 10 times x, so those are numbers of tickets, and then multiply by total price. The full price is 10, right? So this one equals, so that's what we have. This one equals, so this is $10 each, and this is $7 each. Now then we get this is equals to 1001. Let's solve the equation. Let's multiply 10 on both sides, and we just get 31x plus 21x plus 70x equals 10,010, right? And this implies 91x equals 91x is 1,001, and here we get x equals 110. Right? Just divide 91 on both sides, so we get the answer is 110. Question number 6. The following is a sheriff badge that has 10 equal sides, right? So those sides are all the same, and then the angles are all the same. So here's marked as 60. So each of them are 60, 60, 60, and 60. And x is the angle we need to find out. Okay, if we connect those points, let's say if we connect those points here. Now each angle, because it's isosceles, but with 60, so they are all equilateral. That means those sides are all the same, right? So their sides are all the same. What do we have inside? Accordingly, what we have inside is a regular pentagon. We have a regular pentagon in the interior, in this side. Because those angles are all the same. You see, this one is 60, and this 60, these are all the x, these are all the x, right? All the angles are the same. Okay, and then what do we have in the inside? Obviously, what we have inside is a regular pentagon. Right? Let's see it. So the inside, so this is a regular pentagon. Now, let's figure out what is the angle of the regular pentagon. Well, we know the total angle. The total equals 5 minus 2 times 180. Well, the reason the 5 minus 2 because we have a formula. Right? If we have a pentagon or hexagon, it can be divided into 3 triangles. So we multiply by 180. So in general, if I have n-sided, then it can be divided as n minus 2 triangles. So it's n minus 2 times 180. Right? So the total is this, which is 540. And then each angle, so each angle will be 540 divided by 5, so that's 108. We get this one, each one is 108, okay? So we get right here, this one will be 108, right? So 108 is the degree of each angle in a regular pentagon. And then the x will be clear. So the x will be, because total is, the total is 360, right? So it's 360 minus, you have 260, 60, right? So minus 60, minus 60, and minus 108, and what you have is 224 minus 108, and that you get is 132 degrees. So that is the x, right? So x is 132. All right, so here the main thing is you need to memorize, if you have I-sided, right? So this is, let's say, n-sided polygon, and then the total, the sum of angles angles is equals to n minus 2 times 180. That's because you can divide it into n minus 2 triangles. Now, if it's regular, then each angle will be divided by n. Question number 7. The problem says Jack wrote down several distinct integers, and all of them is between 1 and 20. And then we look at a product of this partial integers. Let's say this n. The requirement is this one is not divisible by 12. And then at most, how many numbers could he have written down? Okay, now first of all, let's see, because 12 equals 2 times 2 times 3. Therefore, if none of them is divisible by 3, then of course the product will not be divisible by 3. So what I mean is this. So first of all, n is not divisible by 12 if none of these numbers is divisible by 3. All right, so their natural thought will be, let's just exclude those numbers which are divisible by 3, right? So let's exclude 3, 6, 9, 12, 18, right? So, okay, so here we have, there's a 15 here, right? 15 and 18, right? So we have 6 numbers here. So let's remove the 6, okay? So then we have 20 minus 6 is 14. So the point is, well, at least we can choose 14 numbers, and they do not include a multiple of 3, and it's satisfy what we need, right? So we have 14 is okay. It satisfy the requirement. Is the requirement. Now the question is, how about more, right? So that's the easier. So how about can we choose 15 or more? That's the question. So if we are able to find some way that we are able to, let's not this way, but another way to somehow cleverly choosing numbers so that we can have 15 or more. The answer is no. Why? Okay, so because let's say if it's 15, right? So suppose it's 15, right? 15 more is the same. Right, so it's 15, that means at least one of them is divisible by 3, right? So that means one of them, at least one of them is divisible by 3, okay? So let's say we have 15 numbers, let me write out. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Right, so one of them is divisible by 3. So for example, let's say this guy is divisible by 3. And then we still have 14 numbers left, right? 14 numbers. So look, for 20, we know it has from 1 to 20, it's 10, 11, from 1 to 20, it's 10 even and 10 odd. Okay, so if I have 14 numbers here, regardless how they are selected, then we know at least from here we conclude at least 4 even numbers here. At least 4 even numbers, because 14, you at most you have 10 odd numbers, so at least 4 even numbers. Okay, so let's say we have 4 even numbers. So this is okay. So let's say this is even, this is even, this is even, this is even. Then you have 3 multiply an even number, multiply even number, multiply even number, multiply even number. This must be divisible by 12, because 12 just need, right? So to look at 12, just 2 times 2 times 3, you just need 3 times 2 even numbers, then it will be divisible by 3. But here you have 1 divisible by 3, and you have at least 4 even numbers. And of course, when you multiply together, you'll be divisible by 12. All right, so this justifies 14 is the best we can do about it, right? So 14 is the largest number. Okay. Question number 8. The problem says that Dan and James each have a measuring tape of length 1 meter, and Dan's tape got stuck in a door and it was stretched by 4 centimeters. Then Jane, her tape was shrink by 5 centimeters because left in a pocket and was washed. All right, and they both use their measuring tapes to measure the schoolyard, and then got the length is 23.75 meters. Now, if we use the James measuring tape to measure what will be the outcome. So here the point is for Dam's measuring tape, the actual length becomes 1.04 meter, and for Jin, the extra, although the mark says it's 1 meter, but the extra length is 0.95 meters. In other words, if I have an object, the true length is, for Dan's case, the true length is 1.04. But if you use Dan's measuring tape to measure, you just only get 1 meter. For Jin, if the extra meter is 0.95, if you use her measuring tape to measure, you get 1 meter. All right, so this tells us if we use the, if we look at the schoolyard, right? So if we look at the schoolyard, okay, so let's look at then the measurement. The measurement will be 23.5. Now, 23.5 is what you got, use Dan's tape, but this is not the extra length of the schoolyard. The extra will be from here. So from 1 meter to 1.4, okay? So this will be 23.74 times 1.04. This is the extra length of the schoolyard. And then look at G, right? So G, what we want to figure out is the measurement for G, right? Okay, the actual length is the same because it's the same schoolyard. So this is just, they are equal. So this is 23, 7 times 1.04. Now you look here. So look at the ratio, okay, the ratio. The extra 0.95 is corresponding to 1 meter, read in James' measuring tape. Okay, so from here, then we get this one. We just go back, right? So we say, okay, we go back here. What you should have is this one will just be equal to 23 times 75 times 1.04. This is the extra length, and divided by 0.95. And this will be the reading, the outcome if we use the tape by James measuring using James measuring tape, and the answer is 26 meters. Question number 9. Here we have four circles, 2 larger circles with equal radius, and also 2 small circles with equal radius. Then they put together like this. The middle one, this is here what we have. This is a square. Okay, so this is square. All right, so now we need to find the ratio between the radius of the larger circle to the radius of the small circle. All right, so let's use a little algebra. Okay, so let's say the radius of the large one, this is R, and then the radius of the smaller one, this is R, Okay, so let's put everything here. This is R, and here we have, this is R, and this is R. Okay, all right. Now let's connect the 2 opposite vertex of the this square, and this is R, right? So this is R, and this is another R. This is also R. Okay, so it's 2 R. Let's recall. So we have so basically we just got a square, right? The side length is R plus R. So R plus R, R plus R, and R plus R, and the diameter. So the diameter will be twice of R. This is square. Now we know the ratio between side length and a square. So if we recall, if I square like x, right? So I have square, and then the diameter by Pythagorean theorem, we know this is just square root x 2 times x, right? So from here we just get, okay, we'll just get R plus R times the square root 2, and this gives us, which is twice of R, that is the diameter. All right, so we can cancel. Let's do some algebra. So we cancel square root 2 on both sides. Recall the 2 is just square root 2 times square root 2, so we get square root 2. All right, so from here, and then we just get R plus R equals the square root 2 times R, right? Square root 2 times R. Okay, and this gives us it's r equals the square root 2 minus 1 m times r. Okay, and this means the r, the ratio r to r, which is, let's say, write r over r. This is just 1 over the square root 2 minus 1. Now, what we need to do is we need to simplify this. Okay, how we simplify this? What we're going to do is we just multiply. So 1 times the square root 2 plus 1 on both sides, on the top and the bottom. So square root 2 plus 1, right? Okay, and this one, the top will just go 2 plus 1, and this we use the formula. So a minus b times a plus b, right? So this is just a squared minus b squared. So a times a, but a times b and b times a, one is positive, another negative, they just cancel each other. So what you left is a squared minus b squared. Okay, so what it has a 2 square root 2 square minus this, which is square root 2 plus 1 over 1, that is square root 2 plus 1. So square root 2 plus 1 is the ratio between the radius of the larger circle and the radius of the smaller circle. So that's 1 plus the square root 2. Question number 10. Here we have 6 friends, A, B, C, D, E, F. They are sitting around a hexagon table as shown. And we randomly choose 2 of them. What is the probability that they are not next to each other? All right. Okay, let's recall the way the basic formula to calculate the probability equals the denominator is the number of all cases, and then the numerator is the number of valid cases, or you call favorable cases, whatever you call it. So in our case, the valid case just means 2 of them, they are not next to each other. All right, the number of all cases is easy to calculate. We have given formula. That's from 6, we choose 2, right? Okay, so it's 6 times 5, 2 times 1, which is 15. So 15 is all the number of pairs. Now let's look at the number of valid cases. Well, to calculate this, you can either do directly, right? You count those pairs which are not next to each other, or you can calculate using the inclusion-exclusion principle. Okay, so this just means the total minus invalid cases. Right, invalid cases means they are next to each other, right? So next to each other, Right, next to each other is easy to calculate. You have 6, like 1, 2, 3, 4, 5, and 6. Now you have 6 pairs, they're next to each other. Total is 15, so 15 minus 6, which is 9. Okay, this tells us the probability in terms of fraction is 9 over 15, and we can simplify this, just be 3 over 5. So 3 over 5 is the probability. Question number 11. For how many integers n, the number n to the power n is a perfect square? So first of all, let's recall that how we characterize a perfect square. Let's look at a characterization of a perfect square. And what we have is, as we mentioned before, so n is a perfect square if and only if this is necessary and sufficient, if and only if all exponents in its prime factorization are even. For example, say 16, right, which is 2 to the 4. This is the exponent is 4. Say 100 is 2 to the square times 5 squared, so exponents are 2, 2, right? Or we say like 2 squared times 3 to the 4. These are all perfect squares. So if this is 2, this is 4, we know this is just the 18 squared, right? So 2 times 3 squared and squared, right? So they're just 18 squared. Okay, so this is how we characterize a perfect square. And therefore, you see case 1, if n is even, then n to the n, the power is automatically even, right? So we just get regardless of what is n, but if it's even, this is already even. When you write, it's the prime factorization. So this is already even when you have, okay, so this is okay. And now case 2, so even numbers are automatically fine. Now, how about n is odd, right? If n is odd, okay, so we have n to the n. How can we guarantee, right? How can we guarantee this n is perfect square? Well, in other words, if I look at the prime factorizations, how can I guarantee that exponents are even? Now this is perfect square. If and only we must have n itself is a perfect square. Perfect square. Now you say, why is that? Okay, let's look. For example, say n equals it's odd, right? So for example, let's say n equals, of course, we can use the pure algebra to demonstrate this, but to simplify the presentation, I just use specific example. Let's say n equals 3 to the power k and 5, say to the power, let's say this is, let's say j, right? So this is the prime factorization of n. And then n to the power n, we know is 3 to the k times 5 to the j, n to the power n. If you remember the rule of exponents, this will be just 3 to the kn and 5 to the jn, okay? All right, so this becomes the prime factorization of n to the n. Now remember, in order to be perfect square, we need this and both of them, these two guys, they have to be even, right? So we need both of them to be even. Now, because n itself, right? Remember, n itself, n is odd. If n is odd, in order to get the multiplications even, we must get both k and j are even. All right, so if you go back to here, you get both k and j, they are even. But if both k and j even, it just means n itself has to be a perfect square. All right. If we combine this thing together, we say there are two valid cases. One, n is even, everything's okay. If it's n odd, n it has to be perfect square. Okay, all right, so m is odd. How many do we, n is even, how many do we have here? We have 15. N is odd and it's perfect square. How we have, okay, we have 1, we have 3 squared, we have 5 squared, and we have 7 squared, right? So we have 4 of them. So, okay, so we have 4 of them. Right, okay, so we have 4 of them. Then, oh, there's 9. There's another 9. There's another 9 squared. So we have 5 of them. Okay, so we have 5 of them. So 1, 3, now 5 of them. If you put them together, so 50 plus 5, which is 55. So in total, we have 55 numbers. That's all even numbers plus odd perfect squares. And then they satisfy n to the 8 itself is a perfect square. Question number 12. The problem says we have 11 congruous small rectangular boxes that put together to form a large rectangular box. Here we have, and the volume of each small rectangle box is 288. The question is, what is the surface area of the big rectangle box? When we look at this picture, it's easy to derive the following relations. You see, this is, here we have, this is h, okay? So then we have, this is also h, right? And this is a, a. Okay, so from here, the first equality we have is a equals 4h. And then we have, this is b, and this is also b, and this is a, right? Okay, so this one is a, this is also a. All right, so then we get the second equality, which is 2a equals 3b. Therefore, we can express a and b, both a and b, in terms of h. From here, we get a b equals 3/2a, which is 8. If I replace that a by a 4h, so that's 8h over 3. Okay, and then the volume of the smaller one, right? The volume of the smaller one is a times b and times h. And this can also be written in terms of h, which is 4h, right? So let's say, okay, let's write this is 4h times 3 over 8h and times h, which is 32, and h cubed. We know the volume is 288. Okay, from here, we get h cubed equals 32 and 288. Which equals 9, right? 288 divided by 32, which is 9. And then we get the h cubed is 3 times 9, which is 27. Accordingly, we get h is 3. So after we get h 3, then we get a will be 12, and then b, if you are h 3, so b will be 8. Okay, so this tells us, this will give us the dimensions of the larger rectangle box. right? From here, okay, so here this one is 2a, therefore this is 24, okay, and then this dimension, this will be a, right? So this a, which is just 12, and then this dimension is h plus b, right? So this is b, okay, so we have this is b, so it's h plus b, which equals h plus b, which is 11. All right, so then we just get the dimension of the rectangle, the big rectangle box is 12, right? So it's here, it's 12, 11, and 24. And accordingly, we get the surface area. Equals 11 times 12 plus 11 times 24 and plus 12, 20, 24, right? And then multiply by 2. So that's how we calculate the surface area, because each it has 6 faces. Each 2 is they're all rectangles. Okay, and then we can do the calculation. We'll get this 1368, which is this one. Question number 13. Here says we have a sequence that's 10, 2, 5, 2, 4, 2, and x. X is a number that is to be determined. All right, it says it satisfies the mean, median, and the mode of this sequence when they are arranged in order for an arithmetic sequence. Well, in order for that to be true, we need to figure out all possible values of x. All right, as the first step, let's first write these numbers in the increasing order. So we have 2, 2, 2, 4, 5, 10, and x. Well, x is, so far we don't know where how large x is and where we should put x. But anyway, so from this, one thing is clear. What is the mode? The mode has to be 2, regardless of what is the x. The mode has to be 2. And then what is the mean? Mean is the average, right? So average, in total, we have 7 numbers. And then we add these 7 numbers together, which is 2 plus 2 plus 2 plus 4 plus 5 plus 10 and plus x. We combine, we simplify, we get 25x plus 7. All right. Now, one thing we can say about the mean is, because x is at least 1, so the mean has to be greater than 3. Right? So this is what we know. The mean has to be greater than 3. Okay. All right. Now, we should find out where should we put x. Let's look at 2 cases. Case 1, that x is no less than 4, right? If x is no less than 4 means the x is on this side. If I put a 4 here, x is on the either 4 or greater than 4. Now for this, if that's the case, we know the median, right? So if I know the median is equals to 4, right? The median has to be 4. If for this case, if x is on the right hand side of 4, then the median is 4, and this number, well, we know they have to be arithmetic sequence. Now the point is, if x is no less than 4, then the mean clearly will be bigger than 4. Okay, so for this case, the point is, for this case, the arithmetic sequence is in the form from 2 to 4 and from 4 to this. Okay, so we have 2, 4, and 20x plus 7. Okay, now it's an arithmetic sequence. So from here we get 2, and from here we also get 2. Okay, so then I derive 24x over 7. This shall be 4 plus 2, which is 6. And from this, I get 25 plus x is 42. Therefore, x is 17. Right. So this is one possible value of x. All right. So one possible value. So this case, x is 17. Now let's look at case 2. Case 2, if x is less than 4, that means if x is on this side, right? So this is case 1, and this is case 2. If x is on this side, okay, again we have, that's right here. So we have the mode is still 2, and the mean is still 25 plus x and plus 7. And the question is, okay, what is the median? Well, clearly, the median has 2 possibilities. Either it's just x when x equals 3, or it's 2. If x is if let's say x equals 1. Now When you look at the 2 case, of course, this is impossible, because if that's the case, you get it has to be constant. We know this one is already bigger than 3. So it's impossible like 2, 2, and something bigger than 3, they can form a arithmetic sequence. All right, so from here, the only possibility is x equals 3, but we need to check whether it works, right? Okay, so that's, let's see, if x equals 3, and then we'll have the mean is what? The mean for this case, again, let's write. So mode is 2. So that's let me write everything. So it's 2, 2, 2, 3, 4, 5, 10. Okay, so the mode is 2. The mode is 2. Well, always 2. And let's see the median. The median for this case is 3. And let's see the mean, right? So the mean, we know it's 25 plus x of 4, okay, which is 4. All right, so we have a 2, 3, 4. Great. This is an arithmetic sequence. All right, so then for this case, we say, okay, we get x equals 3. Right? Okay, so combined together, we have 2 valid options for x, 17 and 2. So if I add together, we get is 20. So 20 is the sum of all possible valid values of x. Question number 14. Here we have equilateral triangle ABC that is on a real axis, and then we load this triangle ABC clockwise until that one vertex reach the position 2013, and we need to find, basically we just need to find the travel distance of the vertex A. So this is the vertex A. We find the travel distance, and then we convert the travel distance into the circumference of a big circle, and then identify its radius. All right, to solve the problem, first let's identify the pattern, like how the triangle is moving. Okay, we start from, this is triangle ABC. So this is A, this is B, and this is C. Okay, so 0 and this 1. Now we roll it clockwise, and then next position, let's say this is A. The next position will be A, and this one will be B. Okay, C will be here. Okay, so this is 2. And then we roll it again. This will be stay there, right? And this will go to be C, and this is A, and this is 3. And then we roll it again. So this is C. Okay, so we roll it clockwise, right? So A will be here, and this is B, and this is 4. Okay, so now the point is, you see, after 3, it will just go back to 0. So we get a pattern here. So this is like cycle, right? So we have cycle 3 here. Then we go all the way. So it will, after this, it will just repeat itself, right? As the motion, it will just repeat itself. Okay, and then all the way goes to, so here you see the distance here, the distance on the along the real axis is 3. All right. Okay, now then we go all the way to here. This is 2013. Let's see. Let's look at the positions of vortices. You see, if we C is corresponding to 3, if it has a 0. Now the point is the position of C is divisible by 3. And then if you look at the position of A, so it's 1 and then 4. That means if you look at all the positions of A, when they are divided by 3, the remainder is 1. And then if you look at the B, so B will be 2, and of course the next one will be 5. So that means the position of B when divided by 3, the remainder is 2. Now let's look at this one. Now let's look at this position. There's a 2013. This guy is divisible by 3, right? So this guy is divisible by 3. This one is 3 times 671. All right, so divisible by 3, and then we say, okay, if it's divisible by 3 means that this is C, right? So this is C. And then here we have, if this is C, then we know this is A, and then this will be B, the one which is before 8, right? Okay, and this is 2012, and the one before 8. Let's just show one more. So it's 2011. All right, and this one will be 2011, and this will be just A, right? So this is A, right? Okay, and this is C. All right, now let's see. Okay, so this is A, B, C, right? All right, so now let's see. This one will be, if we do one more before 8. Okay, so this one will be, this will be, and this will be the C, right? So this will be C. Okay, now let's see. Let's see that how what is the trajectory, the moving trajectory of A? The moving trajectory of A, if we look at this, it's a rotation. First, it rotates around this B, right? This is arc. The degree is 120 because it's equilateral triangle is 60 and 60 together. So that means the first part from here to here, this will be with radius 1, right? So with radius 1, with radius 1. So it's an arc. The degree is 100. It's 120. Okay, so that means this guy is 120 is 1/3 of the full circle. So this will be 2 pi over 3. And the next one from A, this back to A, again, this is 120. So this one again is 2 pi over 3. So this tells us within each cycle, the length of 3, the travel distance equals 2 copies. So 2 times 2 pi over 3. So that's 4 pi over 3. Now, if we start from the side position and all the way to here, right? So all the way to here. Okay. So all the way to here, you see the total along the horizontal is 2021 minus 1. That's 2010, right? Okay, so then we divide into 3, 3, 3, 3. How many 3 we have? It's 3 times 67. All right. Now then within this part, the travel distance. So the travel distance here, from here, the travel distance, we have in total 630 cycles. So 670 times 4 pi over this is 4 pi over 3. So it's 4 pi over 3. Okay, so it's 4 pi over 3. And then you plus, right? Then you plus. And there's one more because here what we have, this is the destination. And there's one more right here. Okay. All right, so this one is extra 2 pi over 3. So we just added this extra 2 pi over 3. Now this is the total travel distance from here. We added together. This is the total. Okay, so this we have. This is the total travel distance of A, right? So this is 2 pi over 3, and this from here is that we just combine them together. All right, now we want this is equals the circumference of a big circle. Let's say the radius is r. So this one shall be equals to 2 pi and times r. R is something that we need to figure out, right? Okay, so now we cancel 2 pi, and this will be 2 on both sides. And then this gives us, so from here, we'll derive the r equals 630 times 2 over 3 and plus 1/3. Okay, so this one equals 3. It's 130, 70, 41, right? Okay, so divide by 3, and this will be 4, 4, 7. And that's the radius or the biggest circle we are looking for. Question number 15. How many integers between 1 and 100 has more than 12 divisors? The answer is 0. Now let's see why is 0. Okay, so say suppose the integer n, it has only prime factor like 2 and 3, so we should write this is 2 to the n and 3 to the n. Okay, let's recall how we calculate the number of factors. Let's recall the number of factors equals because the factors has to be 2 to the something and 3 to the something. And this one can choose from 0, 2 to the n, 0, 1 to the n, and this can 0, 1 to n. All right, so the number of choice, it's by multiplication principle is m times 1, right? Okay, so then we have m times 1 and m times 1. It has to be greater than 12. But meanwhile, you have to make sure that this multiple together is no greater than 100. And then it's easy to see, it's easy to check that you are not able to find to make this work. For example, you say, okay, if I let this n, say m equals 2, for example, you say, okay, let's say m equals to 2, then n has to be greater than 3. So n has at least to be 4. All right, so for that case, you have 2 to the square and 3 to the 4. Okay, so this is already bigger than 100, right? Bigger than 100. So the answer is no such pairs and n. And then you might be asking, oh, why it has to be the factor 2 and 3 can also have like 5. Yeah, so if you do things like 5, let's say 2 to the n, 3 to the n, 3 to the n, and times the 5. But the 5, in order to not go beyond the 100, is either 1 or 2, right? So it's like this or like this, like 5 squared. But if you have things like this, then the number of factors will be m plus 1 times n plus 1 and times 1 plus 1, because here the power of 5 is 1, right? It has to be 1. So it could be either 0 or 1. So that's 1 plus 1. And then you have to, this is, it's greater than 12. So you have n plus 1 times n plus 1 has to be greater than 6. And then again, you just try, you see, you just look at different pairs. Also, meanwhile, you have to make sure this is no greater than 20. And you see none of those pairs will work. And similarly, this is not going to work. And they say, okay, how about 5 and 7? But if it gets larger, the thing gets worse because if this is replaced by 7, then you see the possible choice for this one will be smaller, right? The range will be smaller. That gets worse. Okay, but the point is, if you combine those things together, you find none of them is going to work. So the answer is 0. Question number 16. Alice has a piece of paper in the shape of x degree of a circle of radius 10. This is radius 10, and this is the angle, okay, in the unit of degrees. Right. So now use this to form a cone. So we have a sector, and then we fold the sector to form a cone. The slant length, this is 10, and the height of the cone is 8. Okay, then you see by Pythagorean theorem, we immediately get the radius of a cone. The cone have the base is a circle, and the radius by Pythagorean theorem, clearly we get this one is 6, right? 8 squared plus 6 squared equals 10 squared. Now the point is when we fold the sector into a cone, the base, or we say the arc of the sector, becomes the base circle of the cone. Accordingly, they should have the same length, right? So they should have the same length, and the length of this one is calculated by x over 360. That's just fraction, the portion of 8, and times the 2 pi and times the radius 10. And the radius of this is just 2 pi multiplied by 6, which is 12 pi. Now, these two things, they should be the same. Okay, so from here, we derive the equation. X over 60 times, this is 2 pi times 10 equals, this is 12 pi. And from here, we can solve the x, right? Okay, so we have pi cancel, we have pi cancel with pi, and then we have 10 cancel with this. All right, so from here, we just we quickly get the x. Right, so we get x. This one 2 cancel with, we get the x. All right, so this is 12 and 2 get a 6. Okay, so we get x is 6 times 36, which is 216. Question number 17. Let n be the largest possible area of a right triangle with integer side lengths. One leg is 12. Okay, so one leg is 12. What is the remainder when n is divided by 7? Well, of course, there are a number of right triangles with the integer side length, and one leg is 12, and we need to find the one that is the largest area. Okay, so let's say the hypotenuse is n and this n. Then by Pythagorean theorem, right? By Pythagorean theorem, we have Pythagorean. right? So we have m squared minus m squared equals 12 squared, or we say m squared equals n squared plus 12 squared. Now, at this point, we use one of the most important algebraic equality or identity, which was mentioned before, right? So this one equals n plus n times n minus n is 144. That means we have n plus n, because here we assume they're all integers. We have n plus n equals a, n minus n equals b. So we have a times b is 144. Now, what is n, right? So from here, n, we can just solve just a minus b and divide by 2, right? Divide by 2. What do we want? Because we want the largest area. Well, what's the area? The area equals, so the area just equals 6 times n. So that means we want the largest possible value. What we need to find is the largest. First, we need to find largest possible value of n. Okay, and n is a minus b, so that means we want to find the largest possible difference between a and b, and they have to be divisible by 2. Okay, so from here, clearly, what we should choose is a is 72 and b is the 2. And by this choice, we get the largest possible difference between a and b, right? Okay, so then from here, we just get n is 35, right? So n is 35. So that's the largest possible choice of another length. Okay, so then it's 6 times 35. Well, because 35 is already divisible by 7, we get this one is divisible by 7. So the answer, the remainder is 0. Question number 18. Here we have 2 squares. They are put together as follows. Now, all triangles are isosceles triangle. If we know the side length of the smaller square is 12, then what is the area of the largest square? Now, the first thing we need to do is to figure out which one is the smallest square. When we look at this, this picture, now due to symmetry is clear, so we have these two, they have the same area, right? So this is the middle point. Okay, so if I divide this into 2 parts, and this area and this area, they are the same. So which means these 2 parts, they have the same areas. Okay, then you see, if I look at the tilt, compare the tilt square with this this square, the tilt square has 2 extra parts, right? So these 2 are extra parts. Extra. And there is a part, this part is common. It's the overlap, right? The common part. Now, from here, it's clear. This tilt one has a larger area because there are 2 extra parts, and this triangle is the smaller one. Okay, so from here, we get this one is the smaller one. So we get this one is the smaller one. All right, so then the smaller one, we know the side of 12, and this will be 6 because it says they're all isosceles, right? 45, 45, 45, they're all isosceles. Okay, so this one 6 and this one 6. Okay, then we know the area of the larger one equals the area of the smaller one plus 2 extra parts, right? 2 extra parts. Extra parts. Now let's calculate the area of the extra parts. We have this one is 6. Okay, so then because this 45, the same, so this is 3, 3, 3. Okay, so clearly the area of this will just be 9, and the area of this is also 9, right? So this 90, it's 3, 3, 3. Right, so both of them are 9. Okay, so 2 extra parts. This is 9 times 2, which you get 18. And the area of the smaller one, we know it's just 12 times 12, which is 144. Okay, so if you add together, it's 144 plus 18, so that's 162. So 162 is the area of the large one. That's the tilt one. Question number 19. A number is called a 5 special if the sum of the digits 5, for example, 114, 113, and 2021. Now we arrange those 5 special numbers from in terms of the increasing order. And the question, okay, what is the position of 2021? Right, step 1. First, Of course, there are infinitely many such numbers, right? Because I can just do 5, 0, 5, 0, 0, 0, 5, 0, right? There are infinitely many, right? So first, let's figure out how many of them have no more than 3 digits, right? So it's okay. Number of 5 special numbers with no more than 3 digits. Okay, so algebraically, how we express this? This just means we have A, B, C, and A plus B plus C is equals to 5, because here we include both the 1 digit, 2 digits. That means we allow A or B there to be 0, right? For example, 0, 0, 5 will just be 5, like 0, say 114, so this should be 14, and then say 1, 2, 2, okay, so that this should be 122. Okay, now the point is, if I allow A, B, C to be 0, and this expression includes all 5 special numbers with no more than 3 digits. Okay, so then we just need to find how many of them, right? So what is the number of solutions to this one? So, okay, so this is just whole number solutions. So how we do that? The trick is, okay, so this is kind of standard situation, how we do that. The trick is we do a transformation. So I let A, maybe I just let X, okay, so I put X equals A plus 1, Y equals B plus 1, and Z equals C plus 1. Now, why we do that? Because after I add in 1, then they all become partial integers with X plus Y plus Z equals 8. And then we have a common trick to solve to find the number solutions. Use the insertion, or we say ball and the balls insertion, and sign the code ball and the balls, right? Okay, now the point is, if I can put the 1, 1, 1, 1, 5, 6, 7, 8, and then I have the ball 1, 2, 3, 4, 5, 6, 7. Now all you need to find of the number of partial integer solutions. All you need to do is, okay, I just choose 2 balls, right? So I can put 2 balls in here. Right, for this will be just 2. This will be 3, and this will be 3, right? 2 plus 3. That's one solution. So the point is, in the equivalently, what we need to find is from 7 position, right? 7, 1, 2, 3, 4, 5, 6, 7 position. You choose 2 positions to put 2 bars, and that is, which is 21, right? So, okay, so the number of this is 21. All right. Now let's move to step 2. Okay, so now we look at 5 special numbers with 4 digits. So we look at case 1 first. We look at a 4 digits. Okay, case 1, we started from 1, and then it's A, B, C, right? Okay, so again, we have this time we have A plus B plus C. This will be 4 because I already have 1 here, and they're all non-negative, right? Okay, could be 0. Now by the same trick, right? We can use the same trick. I have, say, it's letter X equals A plus 1, Y equals B plus 1, and Z equals C plus 1. So we have this X plus Y plus Z is 7, and then we get the number, right? So again, use this insertion trick. We will get this one is 6 choose 2, which is 15, right? So which is 15. Okay, so then we get 15 numbers for the case 1. Now case 2, then we go with the 2, right? So we have 2. Then the first one will be 0, 0, 3. The second one is 2, 0, 1, 2, and then 2, 0, 21. And that is what we are looking for, okay? And we have this, it's, you see, this is 21, this is 15. So already we have 21 plus 15, which is 36. And this guy will be 37, and this will be 38. And then what we are looking for will be 39. So 39th position, that is we are looking for. Question number 20. Here we have a picture that has a bunch of triangles, and also we know the ratio between different line segments. What we need to find is the area of the shaded one, FED. Okay. What we'll do is let me connect the BF, and then you see we have this bigger triangle, which is BFC. what I'm going to do is I'm going to use this BFC to minus the triangle of BEF. This one I put, let's say this is 1. And then we have, this is FCD. And then we also have, this is BED, okay? So then this one I put, this is the part 2, and this is part 3. All right, so then we know the shaded one, right? The shaded triangle, which is FED, that's FDE, is the triangle BFC minus the part 1 triangle, minus part 2 triangle, minus this part 3. Right? So this is the part 3 triangle. Okay, what we need to do is let's calculate 1, 2, 3. Okay, so here we have 4 of them, right? Let's calculate all of them. First, let's calculate the whole area of BFC. Now, in the calculation, the only thing I use, the fact we use, the basic fact is this. That's all we need. Basic fact. If we have, so we had to use this multiple times in previous exercises. Now, you see, if we have a triangle, this is, let's say, this is part A, this is part B, and this is A and this is B. Now they share the same height, right? So the edge. And then in terms of areas, the A over B, the areas is the ratio between their bases because they have they share the same height. Okay, now let's do it. First, let's calculate BFC. So we have, here is, this is F, this is B, and this is C, and here is, this is A. Now the ratio of AC to AF, right? So this AC to AF is 4 to 3. Now the area of this one we know it's N, right? So N is, for convenience, I just put 2015 as N so that I don't have to write out the number each time. So if this is N, and clearly we get the BFA, this will be 348. Just use this fact. Just use this fact. Okay, so then I get a total of this. This will be 7. This will be N plus. Okay, we get this will be 7N over 4. You just add them together, right? So N plus 3N over 4. So it's 7N over 4. Now let's calculate part 1. So part 1 we can do is, because we know, let's do this. So here is, this is B, and this is F, and this is A, and this we already know is 3 or 4N. And now let's look at FE, right? So this is FE, and that's what we can figure out, right? Now, what is BE? So we know the BE to EA. So the point is, we're just repeatedly using this factor. So BE to EA is what? BE to EA is 1 to 2. All right, so from here, then we get this one will be the total. Okay, so this one is total. So total, this will be 1/3 of the whole thing, right? So the whole thing is 304N. So cancel. So this will be N over 4. Okay, so we get this guy, it just be N over 4, right? So this guy, it just be N over 4. Right? Now let's calculate the second part. So this one, let's calculate this one. This one is the whole thing, right? So if we put it here, so this is B, and this is F, and this is C, and here we have this is D. Okay, so this is the second part. Now we know the ratio of BD to CD, right? So this is comma 2. Okay, so from here we get this part will be the total, right? The total is 7N over 4 and times, so this is the total, right? Keep in mind, this is total, and multiply by the 522, because this is 322, the whole thing will be 205, right? Okay, so then we get this one equals, this will be 10 to the 7 and to the n, right? Okay, so then we get this part, right? So this part will be 7n over 10. Okay, so it's 7n over 10. All right, now let's calculate the red part. Okay, so let's calculate the red part. Here we have, this is A, this is B, and this is C. here is, this is D, and this is E, okay? This is E. All right, now we need to calculate is this red part. Okay, let's connect this AD. First of all, let's calculate this is ABD, right? Because this, again, this is 3 to 2, so ABD, the total is N. For this ABC, it's just N times 305. And this one, now for these two here, this is 1 to 2. Okay, so then we get this part is N times 5/3 and then times 1/3, right? 1/3. Okay, so the point is I'm not using anything else, just except I keep using this basic factor ratio between areas. All right, so I get this will be just N over 5. Okay, so this will be N over, so this one will be just N over 5. This is N over 5. All right, now let's simplify the whole thing, right? So we have this, all those numbers put here. Okay, so from here, we just get the shaded part equals, so the shaded part equals, let's simplify the thing. So 7N over 4 minus N over 4 and minus 7N over 10 and minus N over 5. Okay, so we end up with, this is 7N minus N, so 6N so over 4, so that's 3N over 2 and minus 7N over 10 and minus N over 5. And this end up with, it's 10, right? So it's 10. It's 15 minus 7 and minus 2, so we get times N, so it's 1006 times N, and which is simplified 305 times N. All right, now what is N? N is 2015, so we can replace this one is 2015, and then we just get this one equals 3 times 403, so that's 1209. So this is the area of the shaded one. So 1209 this. So 1209. Now, if you add all those digits, 1 plus 2 plus 0 plus 9, we get is 12. So it's 12 right here. Now, for this problem, again, the main thing is we just keep using this basic fact. If they share the same height, then the ratio between areas is the ratio between their side lengths, right? Keep doing that.